Everyone, this is Woodruff here. So now that we've done a review of volume and a review of circles, we're going to put those two together today and start our circular volumes with the 3D figure, the cylinder. On the screen here, you can see some examples of cylinders, your soup can, the can holding the nuts here, and some other figures over here. So just to remind what we just did, we've got to remember that the radius in the circle is the distance from the center to the outside of the circle. The diameter is going to be twice that. It's going to go all the way across the circle, and you can see one here going through the center. Remember, that's the diameter. So if you were given the radius for the diameter, you have to double that radius. And if you're given the diameter and you need the radius, you have to cut it in half. Just remember that diameter is the longer word, it's the longer segment. We also talked about the distance around the circle being the circumference, and that's with a capital C, and you can take twice the radius times pi, or we were referring to it as the diameter pi. It's just a little bit shorter. We also talked about the area of a circle being pi r squared. So that was all done sort of in our last lesson, our last worksheet. Don't forget that pi is actually a Greek symbol. It's pi, and it's the ratio of the distance around the circle compared to its diameter. That's what pi is, and it's estimated at usually 3.14. Don't forget there's a pi button on most calculators, all scientific calculators, and you are welcome to use that. That's your most accurate estimation of pi. So today we're going to go on to a cylinder. Now a cylinder is a three-dimensional figure that has two parallel congruent bases that are circles. So I'm kind of circling one here. There's the top of the cylinder, and down here, here's the bottom or the base. Now that base circle would have an area of pi r squared. So if we just took one circle, like one slice out of the cylinder, you could kind of think of it as being a circle, and its area would be pi r squared. Now to get the volume, remember that we need the base area times the height of whatever the figure is. When we talked about prisms and pyramids, we reviewed that. So the base area here is going to be circular. So we're going to take that pi r squared times the height of the cylinder. And you'll notice that's our formula right here. So the pi r squared is the area of the bottom circle times how many circles are in the figure times the height. And that is the volume formula for finding the volume of a can, of a cylinder. So what formula do you use to find the area of the base of the cylinder? It's our area of a circle, pi r squared. Again, we're trying to figure out with volume how much stuff fits in the can. Like, what's the measure of space that's inside the cylinder? So let's do an example here. Here is a cylinder. I'm seeing that this measurement in this red line segment right here goes from the center out to the edge of that top circle. So that would be the radius. So I've been given the radius of 5 centimeters. I've been also given the height of the cylinder, which is 8.3. So I'm going to come over here and I'm going to take my radius and square it. These are the buttons in the calculator. Hopefully you have an x squared on your calculator or some kind of squaring button. So we're going to take that 5 and square it. We're going to multiply it by 8.3, and that number would be 207.5. So 5 squared is 25 times 8.3 would give you 207.5. We still have to multiply by pi, but we're going to stop for a second. And I want you to see that right here. You can kind of see it down here. That is called the exact answer. We have done no rounding, and we haven't multiplied by pi yet. That's called the exact answer, and that needs to be in your work for every problem. When you're working with geometric figures, we like to leave that way. It's precise. If somebody was building something, you want the most precise answer. So we don't round yet. Once you've written down your exact answer, then you're welcome to pick up your calculator and multiply that 207.5 times the pi button. If you can't find a pi button, you can use 3.14, but remember that your answers will be slightly smaller than anything that I'm going to be doing with the pi button. If you're using your phone calculator and it has a lot of places, your answer could be slightly bigger. So just realize that depending on what estimation you're using for pi, your answers could be slightly different when you approximate. That's why we like to leave our exact answer as part of our work. So if you take a look at this one, they're not giving us a picture here, but they're telling us that the diameter of the cylinder, so that circle on the top, all the way across through the center measures 16 inches. Now our volume formula needs the radius, not the diameter. Now diameter is the long segment and I need the short one, so I have to cut this 16 in half to get the radius that I'm going to square. So see where the 8 came from was half of the diameter. I'm going to take the radius squared times the height of the cylinder, and I'm going to stop there for a second. So 8 squared is 64 times 20 gives me 1,280, and I haven't multiplied by pi yet. I haven't rounded. This is called my exact answer. So the volume of this cylinder is exactly 1,280 pi cubic inches. Now to estimate it, I'll pick up my calculator and I'll multiply the 1,280 times the pi button or times 3.14, and it's about, notice we've got the wiggly equals here, 4,021.2 inches cubed. So here are two different cylinders, and I would pause the video right now and see if you can find the volume of each of these cylinders. Make sure your exact answer is part of your work, and then in the end, round to the 10th, which means there should be 1 decimal in your final approximate volume answer. Okay, now that we're back, let's see how you did. Remember that volume is going to equal pi r squared, the area of one of those two base circles, times the height of the cylinder. They very nicely gave me the radius, so that 3 is going to substitute in for the r. And the height is 1.8, so I'm going to take 3 squared times 1.8. In my calculator, 3 squared is not 6, guys, it's 9. And 9 times 1.8 is 16.2 pi. And I'm going to stop for a second. That's my exact answer. Now, when I take the 16.2 and multiply by the pi button, or 3.14, it's now going to be an approximate answer, and it's about 50.9 inches cubed. Did you remember to put your units? Did you remember to put to the third power? Now over here, unfortunately, they gave me the diameter, and for the volume of a cylinder, I need the radius. So the diameter is the long segment, so I need to cut it in half to get the radius. So when I go to do my volume formula, you're going to notice I'm going to use a radius of 6 and a height of 5. I substitute those in, and I'm going to take the radius squared, which is 36 times 5, and I'm going to stop before I multiply by pi and write that down. 180 pi is my exact answer. I had an architect that had some kind of cylindrical shape inside of a building or on a bridge. We want to give that architect and that engineer an exact answer, and they'll use as many places as pi they can to get the most accurate number that they could possibly get. But now I am going to estimate it. I'm going to take 180 times pi, and it should be about 565.5 millimeters cubed. So really what we want to see on your paper, we want to see, what are you substituting in? So the line that I'm kind of tracing right here, we want to see that exact answer of 180 pi, and then your approximate answer should only have 1 decimal place rounded correctly, and your units should have cube because volume is that 3-dimensional, as we've talked about, unit. So there's one last problem I want to talk to you about before I let you go to practice on your own. But we can take the volume one step further and get a weight. And the way we do that is we still calculate the volume of the cylinder. And then at the very end, we're going to have to do one more step. and you'll see that in just a second. So we have a metal paperweight in the shape of a cylinder. The paperweight has a height of 1.5 inches, so that's going to be our H in the formula. The diameter, we got to be careful. The diameter is 2 inches. I need the radius, so I'm going to cut that in half, and that's why they're putting a 1 in. And I'm going to calculate the volume. So I'm going to take 1 squared, which is 1, times 1.5, and that's your exact answer. You'll see me typing this over here because your book kind of skips that step, and we need for you to be able to do that as you head into high school math. I'm going to approximate by taking 1.5 times pi, and the volume of this paperweight is about 4.7 inches cubed, but that's not a weight measurement. Inches cubed is not a weight. It's not pounds or ounces or grams, and in this case we want ounces. So once we have that volume, we're going to multiply by the 1.8 ounces per cubic inch. That's called actually a density. You might have talked about that in science. But when you take that volume times its density, you will get the weight. You'll see that little formula over here. So bottom line is you calculate the volume just like we did, and at the end you're going to multiply by, what is the weight per cubic unit. And that will give you the weight. And this time it's 8.46, and the weight is in ounces. So your final answer is 8.5 ounces. So let's just try one of those together. The Roberts family uses a container shaped like a cylinder to recycle aluminum cans. It has a height of 4 feet and a diameter of 1.5 feet. The container is full. How much do the contents weigh if the average weight of aluminum cans is 37 ounces per cubic foot? Round to the nearest tenth. I'm not going to worry about this piece right now. It's a 2-part problem. I'm going to start by finding the volume. Got to be careful. They gave me the diameter. I need the radius, so I'm going to cut that 4 in half. And there is, that's the height. The 4 stays. It's the diameter I'm going to cut in half. So here's my formula. So the radius is half of the 1.5, which is 0.75, and the height is 4. 0.75 is going to be squared times the 4. That's where I'm going to start. And I'm going to get 2.25 pi. I am not going to round to the 10th yet, and I'm not going to multiply by pi. This is my exact answer. Pick up my calculator and multiply by the pi button, and the volume of this container is about 7.068 feet cubed. I'm actually going to leave all the places out right now. I'm going to try to just round at the end. You could leave this on your calculator. And now I'm going to multiply by that 37 to get the ounces, because it's 37 ounces for 1 cubic foot. So now I'm going to take the 37 times my 7.06 cubic feet to find the weight of this. So I multiply that, and you should be getting 261.5 ounces. And notice I round to the 10th at the end. So you find and calculate your volume just like you did, but when you get to the end, there's an added step of multiplying by what's called the density. You don't need to know that, but that 37 ounces per cubic foot, we multiply times the number of cubic feet, and we get the weight, in this case 261.5 ounces. So there's a couple problems here that you could try. So I'm going to leave this up on the screen. Pause your video and see how you do finding the volume of these two. Okay, now that we're back, they gave you the radius. So we're going to take the radius squared times the height. We get 18. 18 pi would be your exact answer. And when we take 18 times pi, you should have gotten about 56.5 cubic centimeters. And again, that's your exact answer, and that's your approximate answer. We want both of those. Over here, be careful. They gave you the diameter, so you need to cut that in half first. So it would be 4 squared times 8. That's 16 times 8, which is 128 pi. Write that down. Now go to the calculator and multiply to get your approximate volume, which is about 402.1 inches cubed. If you need to, pause the video to check your work. Pause it, because I'm going to move on to one more problem. Okay, final practice for you. A scented candle is in the shape of a cylinder. The radius is 4 centimeters and the height is 12 centimeters. There's the first part of the problem, guys. Find the mass of wax needed to make the candle if 1 cubic centimeter of wax has a mass of 3.5 grams, round to the nearest tenth. See what you can do with this one, please. Pause, and we'll come right back. Okay, so this is kind of a two-part problem. We're going to first of all calculate the volume. We've got a radius. Thank you very much. We don't have to do anything with it. So we're going to square the radius, multiply by the height, times pi. We're going to square the radius, 16 times 12, and we're going to stop there, 192 pi. That's our exact answer. And now to get our approximate answer, we'll multiply by pi. So take 192 times pi and leave that number in your calculator. Leave the whole thing. Don't round it yet. Now to get the weight, we're going to multiply by the 3.5 grams per 1 cubic centimeter. So we're going to multiply by 3.5. And when we do that, we get about 2,111.2 grams would be the weight of the calendar. Again, if you need to pause and take a look at this, take a look. And that's it for today. I'm just going to ask you to try to do a couple problems that involve finding the volume of cylinders, and then a couple that have also going further this extra step of multiplying to get the weight. I hope you have a great day, everybody. We'll